Well, hello, welcome back. We are going to continue on working with finding volume of spheres and some other composite figures. Now, the volume of a sphere is going to be given to you. Like, that's not one that you necessarily have to memorize. That's our formula that is right here. And you can see that it's 4/3 times pi times the radius cubed. Okay, when we're working with volume, that's a cubic unit, so we're going to use this radius. It's almost like a length times width times height, where they're all the same. Okay, so 4/3 pi r cubed will get us the volume of a sphere. Here's a nice little example that you can look at. Let's move on and do one together now. So a sphere, that's just a ball. Find the volume of a ball, or a sphere, with a diameter of 10 inches. So knowing that the diameter is 10 inches tells us that our radius is going to be 5 inches. That's that spot from the center out to the edge. That's our 5. So we're going to use that formula, volume equals 4/3 pi r cubed. And then we'll just plug those in here. So 4/3 times 3.14 times r, which is 5, cubed. Make sure that when you do these, you're going to put them in the calculator. You can put it in just exactly like you see it here if you want to. Okay, but the important thing is that you're going to have to cube the 5. So I'll put one of these in the calculator. I don't know that we'll necessarily do all of them together. I have a Casio calculator right here, although the TI calculators are still pretty much just the same. So let's go ahead and get out of here, and I'm just going to put in 4/3. So you can write it as 4 divided by 3 times 3.14 times, and then your calculator will do this correctly, but you know what? I'm just going to make sure by doing parentheses 5 to the 3rd power. Even without parentheses, the calculator would do this correctly because it's going to do the exponent before it does multiplication. So it would do that 5 cubed first anyways. Now, this doesn't say what to round it to, so we'll just round to the nearest hundredth. I think that's appropriate since we went out to 2 decimal places with our pi. So we could then say just 523.33 cubic inches. Please make sure that you're aware of that label. Always be careful with it. Now for the second one here, find the volume of a sphere with a radius of 3 meters. So it's the same thing. It's still just a ball, except it's a little bit bigger of a ball because this is 3 meters and it's not a diameter of 10 inches. Also notice that they do give us the radius this time. So we're going to use 4/3 pi r cubed. And this time our radius is just 3. So 4/3 times 3.14 times 3 cubed. We don't need to cut that 3 in half because it's already the radius. And you put that into your calculator, you should hopefully get 113.04 cubic meters. Okay? All right. Let's keep moving on. Next, we're going to find the volume of a cylinder. Now, a cylinder, you could think of that like a can, right? If we had a can of soda or something, a cylinder is going to have a round base and then vertical sides. Now, this formula that's written right here, this is our volume of a cylinder formula. That one is not hard to memorize. After all, it's just the area of a circle, and then you take it times how tall the can is, or the cylinder. Okay, this probably would be given to you on most tests at this level, but just be aware as you progress through math, it's less likely to be provided for you. So actually, you would do this for pretty much any prism. You find the area of the base. This isn't a prism, but you find the area of the base, and you're just going to multiply it times the height. That's a very standard thing to do to find volumes like this. Okay, so in this particular cylinder, it says find the volume of a cylinder with radius 12 centimeters, so they give us the radius, and a height of 65 centimeters. So I always like to think about drawing it out just to make sure I have the right picture in my mind here. Now, even if it's not drawn to scale, it's not, this is 65 centimeters. And then the radius is 12. So I'm going to put a little dot on there and put that there. And we call that 12 centimeters. Okay, I know that my formula, which is provided up there, is just volume equals pi r squared, so the area of the circle, and we'll take that times the height. Okay, so 3.14 times 12 squared times 65. You put that all into your calculator. Notice this is all in centimeters, and we end up with 29,390.4 cubic centimeters. Okay. Again, make sure you remember your label. And it did say use 3.14 for pi, so that's why we did that, and that's why we got the answer that we got. Now for this next one, it's still a cylinder problem, so it's not really much different, except there is one little difference here, and that is they say, let's this time use 22/7 for pi instead of 3.14. So we're still going to get an answer that would be really close as if we had used 3.14, because 22/7 is very close to that. But I mean, neither one of them are exactly pi, so it's really tit for tat. All right, the diameter of 14 inches and a height of 15. So I'm going to think of it like this. Make a little cylinder down here. I know that this is 15 and this is 14, and that's all the way across. Okay? So what I know is if I have a diameter, I probably better use the radius because my volume is equal to pi, which I'm going to use 22/7, r squared. My r in this case is 7. The radius is half of 14 times the height. Okay, so 22/7 times 7 squared times 15. Let's go ahead and we'll just come here. So 22/7 times 7 squared. You can also use a little x squared button. Your calculator probably has one of those. And then times 15. Now I didn't use parentheses on any of these because I'm pretty careful with my calculator and I know the order of operations that it's going to do. Some people like to do fractions using a little fraction button. Your calculator probably has a little fraction button and you could have done 22 and then you do that. And some calculators will even write it and make it look just like this, write it as a fraction using that math notation. Okay, but anyways, you're going to get 2,310 cubic inches. 2,310 cubic inches. Okay, so that's volume of a cylinder. Now, we're going to next look at some composite figures. Composite means putting things together. So what we have here is you can see this looks almost like a rocket or a bullet, or if you turn your head sideways, like a grain silo. I grew up on a farm, so that's the first thing I think of. But what we have here is we have a cylinder, and then we have like a little end cap, and this is like half of a ball or half of a sphere. That's what that comes out to. So now let's actually look at an example kind of like that. Find the volume of a composite solid shown above. So that's this. If the radius of the base of the cylinder is 3 inches, so that means that if the radius, so from this part right here, okay, that to there, we'll call that 3 inches. And the height of the cylinder is 10 inches. And you might think that we need more. You might be like, okay, well, they told us about the cylinder, but they didn't tell us anything about the sphere. Sure they did, because this sphere connects onto here just right there. And so that means then that if the radius of this circle is 3 inches, then the radius of our sphere is also 3 inches. And that's actually all that we needed. We're good on this. This composite figure is going to be made up of two things. It's going to be the volume of the cylinder plus the volume of, this would be a hemisphere, right? But the half sphere, we'll call it. Okay. So the volume of the cylinder is pi r squared h, and the volume of a sphere is 4/3 pi r cubed. Now, since we only want half of a sphere, we'll actually take that times 1/2. You could also just take this and divide it by 2. That would be fine as well. But I'm just showing you what this would all look like if you kind of wanted to write out this all out in one formula. All right, so now let's find the volume of our cylinder. So we're going to use 3.14 like the problem says for pi. Our radius is 3, so we have 3 squared. And then our height is 10. So we'll do something like that. And then I'm going to put that into the calculator that I have here to the side. 14 times 3 squared times 10. And I got 282.6. Cubic inches. So the cylinder part of it is done. And then for the sphere, if you want to go through and put this in, just 4/3 pi r cubed, and then divide it by 2 at the end, you can absolutely do that. Maybe that's how you want to do it. You can. Me personally, I would go through. I'd say, oh, let's cancel that out. 2 and 4 reduce because we're comfortable with fraction work. We can do this, and now I just use 2/3 pi r cubed. I'm going to get the same answer. Okay. If you don't like that, then don't do it that way. Do 4/3 pi r cubed, and then in the end, divide your answer by 2. Okay, so I'm going to do it this way. 2/3 times 3.14. Make sure you actually use 3.14. We've talked in the past about how some of these calculators have a little pi button, but you don't want to use that unless you're told to use it, because you're going to get an answer that's just a little bit different. If the problem tells you to use it, well, that's one thing. You should definitely listen then. Okay, so we have 2/3 pi r cubed. And I get 56.52 inches. Again, the reason why I use 2/3 is because it was 4/3, but because it's only a hemisphere, or half a sphere, that's why I ended up cutting it in half. So when that's all done, we get 56.52 cubic inches, and then we're going to add those together. We add them up, we should get 339.12 cubic inches. Okay. The next one we've got is a box, and we're going to cut a cylinder out of the box. So this is actually going to be the volume of a box minus the volume of a cylinder. We're going to cut that cylinder right out of this box. Well, the volume of the box is pretty easy. That's length times width times height. And the volume of the cylinder is pi r squared h. So that's what we're going to have to end up subtracting from these. Okay, so let's get busy. We've got 40 by 80 by 30, it looks like. Okay, so that will be our length, width, and height here. 40 by 80 by 30. That's the volume of the box. And then the cylinder, notice that it gives us this right here. And if you look closely, they actually give us the diameter. The diameter of this is 28, which makes the radius to be half of that, which is 14. And then our height, if we were to stand this up, that's this one right here. We said that that's going to be 80 meters. So here's the numbers that we would use for that. Okay, so we've got 40 times 80 times 30. This is the volume of the box. That's 96,000 cubic meters. And then for the rest of it, for the cylinder that we're going to cut out of this, okay, we're going to take 3.14. That's pi. Oops, I forgot my square down here, didn't I? So let's put a little square right here. So we have pi r squared h. I bet you thought I was going to forget that, huh? Pi times 14 squared. Wouldn't be the first time I forgot something. Times 80 times the height. Now, if I get a number bigger than 96,000, I did something wrong, because there's no way I can subtract off more than what I have. All right, that seems pretty good. 49,235. I got a double point 2. Okay, so all we're going to do now is to take 96,000 minus, and I could type that in. I'm going to use my answer key. It's a nice way of making this go a little bit quicker. And all it does is it takes the previous output, whatever it just exported, whatever it just printed to the screen, this part right here, and it just puts it in right there for this variable that's stored as answer. So when I do that, this now gets me the final answer to the problem. That's the volume of the solid that's left after we cut out that can, that cylinder. 46,764.8. And then, of course, that is cubic meters. Okay? Let's look at another one here, another composite figure. We've got, this looks like it's just going to be a rectangular box, and it looks like we kind of have this little round part, like this roof. Okay, so this is going to be a semicircle, and then it's multiplied by its height. What this is actually a cylinder that's been cut in half. That's what that lid is. Okay, so let's go ahead and we're going to take the volume of the box, or the rectangular solid, and we're going to add on the volume of the half cylinder, the semi-cylinder. Hemicylinder? Probably not. Okay, the volume of the box is pretty easy. That's 4 times 6 times 24. The volume of the cylinder, remember the volume of the cylinder is going to be pi r squared. Okay, I can see that if this is 6, then the radius will be half of that, right? If this is 6, the radius is going to be 3. So we'll use 3 squared. So pi r squared times the height. This is 24 inches long. And then because we only want half of the cylinder, right? It's been chopped in half. I'm actually just going to put a little half out front. Whoops. In my head, I was mixing up 0.5 and a half. You know what? I'm just going to use 0.5. You can use a half. You can use 0.5. Either one is fine. Okay. So now let's go ahead and go to the calculator, and we're going to take 4 times 6 times 24, which is the same thing as 24 squared. So 576. Then we're going to add on this half of a cylinder. Okay. So let's go back to our calculator, and I'm going to put that in just like we see it. So we'll put in 0.5 times 3.14 times 3 squared is 9. I'm just going to put 9. I mean, you can do 3 squared if you want. And then times 24. This gets us the volume of that half cylinder. Right? If we got rid of this 0.5, that would be the volume of the whole cylinder. But because it's just like chopped in half and made a lid, that's why it's half. Okay. So all we got to do is add those two up. So I'm just going to do plus. Must have done something weird here. Okay, so we'll take our answer that we just had. We'll do plus 576. This gets us the volume of that whole composite figure, 915.12. Inches cubed. Okay. All right, let's look at these last 3 problems. We've got a couple application problems. I'm just going to work on getting them set up, and we'll get an answer put down for these so you can check these as you go. Farmer John has a wheat silo, so a grain silo that he's going to be storing some wheat in this particular harvest. The shape of the silo is a right circular cylinder, so it's like what we already talked about, right? So it's a right circular cylinder, comes up here, and then it's 35 yards tall, and it's going to be topped with a hemisphere, right? So it's kind of like, whoop, has that top little round part. It's what we've already looked at in the past. Okay, it was one of the first things we looked at. I'm sorry, I'm just horrible. You can kind of see it's a cylinder with a hemisphere on top. Okay, and it's topped with a hemisphere 5 yards across. Okay, so that if it's 5 yards across, then that's our diameter. This is 5 yards. Okay, so it's 35 yards tall, so like 100 feet. This is a pretty tall one, and it's 5 yards across. Okay, see if you can figure out what the volume of this will be. We've already done one like it. See if you can do it on your own now. So what we're going to do is take the volume of the cylinder, and we're going to add to that the volume of the half sphere. So whatever the volume of the sphere is, and then we cut it in half. Right? So the thing to remember then is that our radius is 2.5 yards, because the diameter, that's 5 yards across. So our radius is going to be half that, or 2.5. The volume of the cylinder is pi r squared times the height. Okay? And the volume of the sphere is going to be 4/3 times pi times r cubed. That's the volume of a whole sphere. But we want half of a sphere. So we're going to take that times a half, or divide it in 2. Okay, so when we put all this into our calculator, I'm going to do this real quick. 3.14 times, pi r squared. Man, I forgot to write it there again. Boy, it's a good thing I caught that. 2.5 squared times 35. I got 686.875. I'm going to round that to 0.86 would probably be okay. And then we've got 1/2 times 4/3, so that's just going to be 2/3 times 3.14 times 2.5 cubed. So the hemisphere part of it is much, much smaller. This is a very tall silo, so the majority of the silage is going to be in the cylinder part, not so much in the top part. Okay, so we're going to go through and add these together then. Plus 686.875, and we get 719.583. What are we working in, yards cubed? Okay, and if you rounded that a little bit more, that would probably be appropriate. Rounding this to 2 decimals is probably more appropriate, since that's the most accuracy we have. Maybe even just 1 decimal. I mean, we're talking about cubic yards, so it's kind of your call, unless it says. Okay, the next one, you can see what we have here is a box, and then we have a little part of that box cut out. So it looks like we're going to do the volume of a box, and we're going to cut out the volume of a half cylinder. Okay, and that's what we're going to look at, is the volume of a box minus the volume of a half cylinder, or length, width, height minus 1/2 pi r squared h. Okay, hopefully I won't forget my r squared this time. So this box looks a little different though, because see how this says like 2, and this says 2, and this says 8. Now I've got to do some interpreting here, because I think that what they mean here, when they drew these little arrows over here, I think they mean that like this length right in here is from there to there. I'm pretty sure they mean that to be 2 centimeters. Not this is 2 and that's 2, because if that was the case, it wouldn't fit because the whole thing is only 4. Okay, so I got to do a little interpreting here, and if I'm wrong, then I'm wrong. But I'm pretty sure they mean that to be 2 uh, 2 centimeters. Okay, so our length, width, and height here we've got 8. It's 8 tall, or it's 8 deep, and by 4 by 4. So length, width, and height is going to be 4 times 4 times 8. All right, that's going to be the volume of the box, which is 128 cubic centimeters. Now our cylinder, we would use pi r squared, and so if this whole thing is 2, then that makes our radius to just be 1. Right, so we're going to do 1/2 times 3.14 times r. If the diameter is 2 centimeters, the radius is 1. So I'm going to put 1 squared, and then the height of this is 8 centimeters. Okay, and again, that 1/2 is out there because we just want half of a cylinder. We're just chopping out just the half, a semi-cylinder, I guess is the best way to think about it. So I got 12.56. Okay, now that seems pretty small, so I'm going to think about those numbers here for just a minute and make sure that those all seem legitimate. Okay, so I thought about it for a second. I actually decided to do the problem another way, off camera here, and you can see that all I did was I actually just wanted to find the area of the base. I decided I'm going to do this a little differently. So I found the area of the base, and then I'll take that times the height. So what I did was I found the area of this whole rectangle, which would be 16, and then I chopped out this little semicircle. The semicircle is pi r squared, and so if r is 1, it'd be pi r squared and 3.14. And then we cut it in half, 1.57. Now in doing this, I ended up getting 14.43. That's the area of this shape right here. And then all I got to do is take that times the height if I were to stand this up. Because remember, it's just area of the base times height. And when we do that, I get 115.44 cubic centimeters. That's the same thing we get up here if we subtract those numbers. So I just did it 2 different ways just to double check and make sure that I was doing it right. Okay. All right, last one here for us to look at is an oil tank, which is in the shape of a cylinder, is 4 meters high and a diameter of 6 meters. So it's a cylinder. It's 4 meters high and it has a diameter of 6. So if it has a diameter of 6, then that means that the radius is going to be 3 meters. Keep that in mind. Okay, because our diameter is 6, that means our radius is 3. So we always kind of want to make sure we know what we're talking about. Now the last part of this that you definitely want to pay attention to is it's only 2/3 full. We'll get to that in a minute. First thing we're going to do, let's see, it's an oil tank, so I'll use black. So it's only 2/3 full. There we go. So we'll use the volume is equal to pi r squared h, and then in the end we'll take it times 2/3 because it's only 2/3 full. So we'll use 3.14 times the radius, which is 3, times the height, and we'll take that times 2/3. So the volume of the whole cylinder, not just the oil, the whole cylinder, if I do just 3.14 times 3 squared, boy, doggone, I forgot to write it again, times 3 squared times 4 is 113.04. Then we've got to take that whole volume, that's the volume of the entire tank, and we're going to take that times 2/3. So just take it times 2 divided by 3. That's how you do 2/3. Please don't use 0.66 or 0.67. Use 2 divided by 3, or 2/3 on the fraction button, and that gets you 75.36 cubic meters. Okay, so those are some composite figures. I hope this was helpful to you. I know that some of these are a little bit tricky. Go back through and rewatch this a couple times and try doing it on your own. Check your answers with the calculator. I hope mine are all right. I'm sorry if they're not. I do make mistakes too, but hopefully this was helpful to you. All right, goodbye.